let's briefly review what we should know about polar coordinates. So first of all, this is a new system of coordinates. So in the Cartesian coordinates, we have x and y, which are the distance from the axis, from the point to the axis. In polar coordinates, we have r and theta. R measures the distance from the point to the origin, so it's this length, and theta represents the angle measured from the positive direction of the x-axis and then increasing as it goes counterclockwise. So the same as angles for trigonometry. Now, by trigonometric relations, we can pass from polar to Cartesian and vice versa. So x is r cos theta and y is r sin theta from the triangle. And similarly, from Pythagoras' theorem and trig, we have that r is the square root of x squared plus y squared, and theta is the arctangent of y over x. But in general, depending on which quadrant you are, since arctangent only gives you an angle that's between negative pi over 2 and pi over 2, you might need to adjust it. So you're always going to use triangle and trigonometry if you want to pass from Cartesian to polar. Also, we should remember a convention. We said that r is the distance from the origin, so it should always be positive, but we want to assign a meaning to r being negative as well. And the meaning is that if you have negative r theta, that's the same point as r theta plus pi. So example, if r is negative 3 and theta is pi over 4, you take pi over 4 and you add pi, so you get down here to pi plus pi over 4, and then you go to distance 3 from the origin. So this point, which is 3 pi over 4 plus pi, could also be represented as negative 3 and pi over 4. Then we want to discuss curves in polar coordinates. So these are curves whose equation is given as a relation between r and theta. So r is a function of theta, typically. And an example could be r equals 3 cos theta. If you want to pass from polar to Cartesian, then you're going to use these equations to eliminate r and theta. But sometimes, and that's the use of polar coordinates, a curve will have a simple expression in polar coordinates, but not so simple in Cartesian. That's, for example, the case for cardioid, limacon, and things like that. Then we should remember how to find the area between two angles, alpha and beta. So that's given by the following formula. 1/2 integral from a to b r squared d theta. And if this is your curve, and then this is your angle alpha, and this is your angle beta, remember that here we have a radial grid, so integrating from alpha to beta means considering all these rays, and so it will give you the area spanned by those rays as we go from alpha to beta up until the curve. So those are the most important things. Now to discuss other types of questions like find the tangent line, we will need to express the polar curve in parametric form. So this is not parametric equation because parametric means x and y are given as functions of a parameter. Here we just have an equation involving two new variables. So in order to obtain a parametric description, we're going to use these equations. X and y are r cos theta and r sin theta, but in our case, for the curve, r is going to be a function of theta. So here you get x to be r of theta times cosine of theta, and y r of theta times sine of theta. So in this way, you have x and y as functions of one parameter theta, and that's a parametric form. And then you can address questions such as find the tangent line by finding the slope dy over dx with the usual formulas for parametric curves.